Let us multiply two numbers 568 and 679 without using calculators. It may take time because we will do usual multiplication, term by term multiplication. After following that process, we get answer 385 672. If we do it with the help of calculators, it may take 2 or 3 seconds. But what if we have no calculator? It will take a long time. Before invention of calculators, it was a very difficult task to do these type of calculations. Mathematicians invented logarithms to tackle these kind of calculations. In this video, I will tell you brief introduction of logarithms. Logarithm is the process that changes multiplication into addition and division into subtraction. These are a bit easier to calculate, as addition is anti-process of subtraction and multiplication is anti-process of division. In the same way, logarithm is anti-process of exponentiation. Abu Muhammad Musa al-Khwarizmi, a Muslim mathematician, gave the idea of logarithm. He is also inventor of algebra. Later on, John Napier extended his work on logarithms and prepared tables for logarithms. He used E as a base for preparation of logarithmic tables. Professor Henry Briggs prepared logarithm tables with base 10. Anti-logarithm tables were prepared by Jos Burgi in 1620 AD. Let us discuss some real-life applications of logarithms. Logarithms are used to know the magnitude of earthquakes. Logarithmic functions are used to measure the pH level of chemicals, where pH equals negative log concentration of hydrogen ion. The exponential growth can be measured using logarithmic functions. For example, the money growth rate at a given fixed interest rate can be determined. For example, you have 40,000 in your bank account at interest of 4%. With a logarithm, you may know when your money will reach 42,000. Now what is logarithm? Let us define logarithm of two real numbers. If a raised to power x equal to y, then x is called the logarithm of y to base a and is written as log base a y is equal to x, where a greater than 0, a is not equal to 1 and y is greater than 0. So this is the logarithm of positive numbers. These relations ax equal to y and log base a y equal to x are equivalent relations, and they are called exponential relation and logarithmic relation respectively. When one relation is given, we can find another relation. So a raised to power x equal to y if and only if log of a raised to power y equal to x. They are equivalent to each other. To explain these remarks, observe that 3 raised to power 2 is equal to 9 is equivalent to log base 3 power 9 equal to 2. Similarly, we can say that log base 3 power 27 equal to 3 is equivalent to 27 equal to 3 raised to power 3. Let us find log of 4 raised to power 2. Suppose it log 4 raised to power 2 equal to x. Write it in exponential. We will get 4 raised to power x equal to 2. We replace 2 with x and eliminated log. This is called exponential form. 4 can be written as 2 raised to power 2 whole power x equal to 2. So 2 will multiply by x. We will get 2 raised to power 2x equal to 2 raised to power 1. So in the base there is 2. So we will get equal powers. 2x equal to 1 and x will equal to 1 by 2. So log 4 raised to power 2, 4 in base is equal to 1 by 2. We will deduce some results from this definition. If a raised to power 0 equal to 1, then log of a raised to power 1 equal to 0, where a is in base. Since a raised to power 1 equal to a, then log of base a is equal to 1. We have to find the logarithm of 278.23. We will round off it to 4 digits. We will get 278.2. Here before decimal there are 3 digits. Its characteristic will be 2. We will use logarithmic table prepared by John Napier. In top left column, we will move down and we will find 27. In right side, we will go parallel to 27 and move in the column of 8. We will get 4440 there, and we will find in difference of 2 columns. There is 3. We will add it in and we will get 0.4443 as mantissa. So log 278.23 will be equal to 2.4443.